Hi guys, Buildzoid here, and this is going to be an update on the R9 290X Matrix situation. And the situation is this. And yeah, it just gets stuck on 97. So the card does not work. Or actually no, we've gone from it didn't work at all when I first got it to it kind of worked, except most of the VRM was missing. And now we're back to it doesn't work at all. Though at least it's not smoking, so so I guess that's a win. The issue is at this point, there's nothing I can do. I think I've done everything correctly, and it still doesn't work. So we have the multimeter here. It's set to voltage. So if we check our VCore, we have VCore. All right, we have 0.9, like almost 0.9 volts, which is a little bit it's enough to boot a 290X. Like a 290X that's healthy, it'll boot with this. And in fact, if you caught the 5-hour live stream I did of the e-powering process, the initial part of the process, you would know I did have the card firing up off of the e-power without its own without its own VCore VRM. So I already had the VCore e-powered, and then the only issue on that live stream that I ran into was once you installed the AMD drivers, it would turn off VDDCI, it would turn off the memory VRM, and basically the card would stop working once you got into Windows. So since then, I've basically been just trying to fix the whole it doesn't work once the AMD drivers initialize issue. And at this point, the card actually, now it doesn't work at all because it doesn't post. So yeah, we've gone all the way to it doesn't work. And unfortunately, at this point, there is nothing I can think of that'll get it further, because every single voltage on this card is present. So we have memory power, right? 1.5 volts. Memory power is running. VCore is running. We already showed that. VDDCI, up and running. So that got e-powered. Initially, originally, there's a small chance I blew up the memory controller, which I need to stop, I need to stop doing that because I blow up too many memory controllers. But the one issue is that at some point, I had the card in a condition where it turned on and VDDCI was like 1.1 volts. And that shouldn't hurt a 290X, but it was 1.1 volts before I hit the power supply off switch. And as you can see, the multimeter, there is actually an option to put it into a static refresh instead of a averaging, because right now it's basically averaging all the measurements together towards the value it comes up with, which is why it takes some time to go between values. And there is a way to turn that off. I just normally don't have that turned off, which I think if we just go to shift, and then, oh no, that's delta. Yeah, there, now it's on static updates, right? Anyway, so I'm not sure. Maybe it overvolted a lot more than 1.1 volts, but 1.1 volts should be fine for VDDCI. The issue is, earlier today, I started work. I woke up and I went back to working on this card because that's just how I am. I literally can't rest until this bloody thing works, is kind of the situation we're in right now. At this point, though, I think I'm going to just have to resign myself to it being very, very dead. There's seriously 1 volt across me? Oh, I guess it's because I'm not holding. Okay, well. Anyway, we're going to put it back into... Oh. That's just there to hold it at an angle so you guys can read it, because otherwise if it was facing straight up, it wouldn't be legible on the camera. So yeah, VDDCI is up. 0.95 volts, that's up. 1.8 volts is up. Yeah, there. See? So 1.8 volts is running, 0.95 volts is running, VDDCI is running, memory is running, VCore is running. The only thing that isn't running is the actual core, as the card won't initialize. And I have no idea. I straight up don't know at this point. Is it, yeah. Um, so that's kind of that. It's just like, at this point, I can't get it to run anymore. Because all of the voltages are running, right? I even have schematics for the card, and I've checked all of the different, well, not schematics, but I do have a board view for the card, and um, all of like the enable power good signals, all of that, that's correct. Like as far as the core is concerned, everything is like the core is being told by the rest of the card that everything is fine. So why the core won't start is like, I don't know. Like the core's either dead or yeah, like it is probably just dead. Because like there's like I've e-powered 290Xs in the past. So like, well, to about this level of success, I guess. Yeah. Um, it's funny. I've never gotten past the point of like getting the AMD drivers to run on an e-powered 290X, which is really really stupid. Which is just like, yeah, freaking AMD drivers. Luckily, I still have a pile of like dead 290Xs that like I don't know if the cores are good on them, but they all have like VRM damage, so it's not like I have a shortage of cards to e-power. So I can move on to working on those instead of this. But yeah, it's the funny thing is like it's not that big of a loss to lose the Matrix, because as far as I know, the 290X Matrix doesn't do like, okay, it has a memory heating system, which is kind of like, okay, well that's kind of neat, I guess. For you know, if you're gonna run Sub-Zero, but not big deal in my opinion. It has software voltage control for all of the different rails, but at this point it's like, would it really make a difference if I added a trimmer to the card? Nah. Right? For like 0.95 volts or something, it wouldn't make a difference to add a trimmer. So that's no big deal. Like in this condition, it's just like, yeah, that doesn't bloody matter. And yeah, it just doesn't work, which is great. And the one thing I regret is that I didn't try start the card earlier today, because I literally like, oh, I didn't finish that sentence, did I? So yeah, I woke up, I went back to working on this card, and basically today I just came to the conclusion, you know what? Screw it. I'm e-powering the VDDCI VRM, because basically the whole issue with the AMD driver was by the time it got into Windows, the driver would turn off the VDDCI rail, and then everything was really bad from there. And I tried all kinds of things like pulling enable resist, like there's transistors on GPUs that are used to enable and disable the various voltage regulators. So if you pull all of those transistors, it basically forces all of those regulators to run all the damn time, which is why like the memory VRM is running, right? And all of that, like this won't shut down. 0.95 volts won't shut down. 1.8 volts can't shut down. None of these regulators is capable of turning off any longer because the enable transistors are all gone. And this is just kind of the easiest way, in my opinion, to get things to work. I have a GTX 480 that's set up the same way, where it's just like, yeah, you turn that thing on and it's just like it runs or it's dead. Like the core is either dead or the card runs, because it doesn't have a way of turning off any of the VRMs. Like you feed it the correct, like you feed it 12 volts and 3.3 volts and it has to turn on. Anyway, so this card's in the same condition, which is why everything runs, but the card doesn't. And yeah, and so I pulled all the transistors. That didn't fix the VDDCI turning off, so, you know, and it got steadily more and more extreme, where I was like the vCore power good signal is forced. Like there's a bunch of forced power good signals now on the card, where it's like previously that I didn't bother with them because the VDDCI, like it would turn on initially and then it would shut down by the time we got into Windows. And in theory, maybe cutting the I2C interface to the 3567B would have fixed that, where like the VDDCI would work and the rest of the card like VDDCI would stay turned on even after Windows initialized, because I think what was happening was the AMD driver talked to the 3567B, and the 3567B would tell it, like, yo, everything's all freaking weird, because, like, the vCore VRM's, being replaced. And then the driver would be like, yeah, cool, so turn off VDDCI, and that would just crash the card. Because the VDDCI powers the memory controller. So if the memory controller is not being powered, guess what? It doesn't bloody run, right? But now it doesn't run at all. And the VDDCI is e-powered, and everything is e-powered, and it's just like, and I just don't know if it was still working before I bolted on the VDDCI e-power or not. So, yeah, that's not great. That's really not great. So, anyway, I guess let's turn this off. Take a look at the front of it, because obviously looking at the back, there's not that much to see. I mean, you kind of get the idea that there's something horribly wrong with the card, but you can't quite tell what just yet. So, at this point, I'm just probably going to use this for parts. I might be able to, like, cut off the memory VRM and keep using the memory VRM, because it's, like, on a lot of cards, the memory VRM gets laid out, like, super all over the place, where you have just, like, a controller sitting in the middle of freaking nowhere for no reason, because, well, there was space there, so that's where we put the controller. It was like, could you not do that? Like, it makes it really awkward when you want to salvage VRMs off of a card. So, yeah, like the VDDCI is a perfect example of that, right? The VDDCI VRM lives over there, but the controller for it is here. So if you wanted to make if you just wanted to, because the vCore VRM is toast, so if I just want to rescue the VDDCI VRM from this card to use on some other project, it's impossible, because you need the entire bloody card to have the VDDCI VRM working. So, yeah, and a lot of cards will have the memory implemented, like memory VRM implemented like that, where it's just like, oh, you cut part of the card off? Well, now VMem doesn't work anymore. So, yeah. Anyway, and in fact, even like RX 480s are laid out like that in a way where you try to cut off a lot of the card, and then you're like, well, you can't trim the vCore VRM to the level you'd want to, because the freaking controller is in front of the vCore VRM instead of behind it. Anyway, let's pull this out, get it out of the way. So, power this off, and let's flip this monstrosity over. So for testing, obviously I just have the Morpheus heatsink on there, and actually I can hold it this way, and you guys won't see the card in shot. So, yeah, there's the monstrosity. So this right here is actually a VRM that came off of an RX 480, and so, like, overall with this project, like, I'm sad, like, this is, you know, the thing is I didn't get the card for free. So at this point I'm just kind of thinking of like, well, good things that came from me trying to do this. I learned how to, I got better at hot air rework. I'll say that. I got, like, a lot better at hot air rework. Like, for the first time ever, I've managed to actually, like, pull a MOSFET and then replace a MOSFET without, and have it work, right? Like, that's not been until basically this card, I've never done that. I've never replaced a MOSFET with hot air. I've pulled stuff, I've not replaced it. So, you know, it's just like, yeah, I was great at, like, scrapping things for parts, and then not able to reuse said parts, not properly anyway. So anyway, so this is a RX 480 VRM. It's a 6-phase vCore VRM off of the RX 480 GTR. Great vCore VRM. It's basically the same vCore VRM you'd get on a Fury X, which is cool. And I added an I2C header so that I can use the lovely Infineon USB 005 dongle. So this plugs in, and I like this originally when I built this was you needed to use a trimmer, so a potentiometer to adjust the voltage on it, and the voltage range was only 1.15 volts to 2.15 volts, which is a little too high for, like, it's good for memory power. Like, if you wanted to e-power memory, sure. If you wanted to e-power a core, sure. If you wanted to e-power a VDDCI rail, kind of concerning. Like, kind of concerning, right? So I'm kind of happy that I managed to, get the I2C interface working and basically turn this down to 1.03 volts. So that's neat, and it no longer needs a potentiometer. I can just plug this lovely thing in and we get voltage control. So that's cool. So I'm happy that this is now implemented that way. Also, you may notice that while this was running, I didn't have the extra power connectors plugged in on this. When I first built this, I didn't realize that actually, you know what would be much cooler than having to because basically when I was first doing e-powers, at some point I realized, wait a minute, having a card with 3 different power boards, right, where the e-powers from EVGA and the Galax Hall of Fame power boards as well, they need 3 power connectors each. So then you end up 3 power connectors for your power board, at least one power connector for the GPU itself, then a power connector for your RX480 VRM, and then another power connector for your HD787 TVRM. HD787 TVRMs are super easy to cut and convert into e-powers. They're by far the easiest cards to do. The only downside to them is they use a chill voltage controller, so you can't a dongle like this won't work, and chill is no longer a thing, so you can't get I'm not aware of there being a chill dongle that you can just buy. So the one downside to those is yeah, you'll have a easy e-power, but it'll be a 3-phase with a relatively low overcurrent protection, so it'll shut down if you try to use it on anything really high power consumption. Anyway, so HD787 TVRM for memory power or VDDCI, because that one actually defaults to 0.9 volts, not 1.15. Anyway, the point is, you'd have your 3 power boards attached, and the card needs 7 freaking 6-pin power connectors, and at that point it's just well, that's no bloody fun. So this, actually this pulls its 12 volts power from the card that it's attached to. So that's really cool. Then of course this right here is basically to make sure that instead of needing 2 8-pin power connectors on the card, I just need 1. So that white wire takes 8-pin, the power from this power connector to here. I also rewired this 8-pin so that it runs with just a 6-pin, because plugging in a most of my power supplies are 6 plus 2-pin power connectors, and well, with the the power board in the way and everything, it's just annoying to plug in those extra 2 ground pins when they don't really the card doesn't the only VRMs on this card that actually the only VRM still powered by the board is the memory VRM. So it's just we don't need a lot of current. So just the 6-pin is going to be fine. Which is also why I'm just using 1 wire to join them together instead of a nice, a higher, a more beefy connection than that. That's a single 18-gauge wire. Anyway, so yeah, that's what's going on with that. Then this right here, well, I figured out a new way to attach e-powers that is, well, I don't know how good it works because I never got to run the card at full load. Right, which is unfortunate, but it looks horrific, but it should be decent in terms of current handling capacity, because there's a lot of cross-section to both of these. So these are V-core, this is ground, this, the smaller connections on the outer edges, that's all ground, and then these center ones are V-core. They're going to be an absolute nightmare to break. Disconnecting this is you need a hacksaw. There's no way you're desoldering this. That is... I'm hacksawing this back off to use on other projects. But at least it's neat that, okay, this style of attachment is viable. But it could work. And then this right here is ground. And so these are actually just well, very fine copper. I'm just going to grab it there. So this is an 8-gauge wire that basically you can see the internal stranding for that. I think it's 8-gauge, might be 4 or something. I'm not sure. Don't really care. Anyway, just took the internal copper stranded cables that it's made up of and used those for this. And then, you just dump a ton of solder into them and you get these very thick metal connections between the power board and the GPU. So when you need to push, in theory, a 290X, you can easily do over 200 amps is really easy on a 290X core. So this should handle, hopefully 200 amps going forward and back. because that's always the biggest concern with the power boards, is just like getting enough of a connection where you don't lose like 300, 400 millivolts just going from here to there, right? Like if you lose a lot of voltage, that's no good. Then I'm going to be scrapping this for parts. There's some SMD capacitors that I can pull off of it. Those are nice, and that's about it. The through-hole capacitors are completely worthless because I think at this point they're roasted, like they're gone. And then pulling them would just make that worse. Like the like how hot they got for how long, I think they're toasted at this point. Yeah, so I'm just going to be pulling like the SMD capacitors for VCore and VDDCI because there's a couple of those. And there's really nothing else worth saving on this card in my opinion, which is like I'm going to pull the core to make an ornament out of it, but yeah. And I'll try to rescue the memory VRM because I think I can pull the memory VRM without breaking it, and then I'll have something more practical when I need to power something like a VDDCI rail, and because this is a 6-phase, which is like super overkill for something that's just VDDCI. Actually, we should take this thing apart, and taking this thing apart is no fun, which is why I think the core is actually dead. Like that, my theory is the number of times I took this thing apart, like put it together and took it apart. Just like I probably rocked the die on the heatsink too much, and I just broke. Like I basically did what thermal cycling does to GPUs over time, except I did it by hand. So I think that's why it's dead. That, or I overvolted the memory controller and blew that up. Like, yay me. Why do I hate AMD GPU memory controllers? Seriously, like. The RX 480 VRM is actually off of a card where I blew up the memory controller as well. Not completely, but that card just artifacted for the rest of time, basically. It never ran properly again. But, yeah, so I'll probably pull the core. You can see the connections over there, which, because I did this after, like, well, you know, you can see the connections for the VDDCI are the same idea as what they are for the VCore, except much thinner because VDDCI doesn't pull anywhere near as much current. Like this is 200 amps easy. This is more like 20 amps in terms of how much current draw it'll pull. So yeah, and you can see, so these capacitors right here, probably going to steal those, probably going to steal those, probably going to steal that one. Maybe this one down here, I might steal that capacitor as well. Yeah, so I'll pull like all the SMD capacitors, but unfortunately, and I might steal all of the MOSFETs in the VDDCI VRM, not that I really have plans for them, but hey, you never know. I might get a card where like there's a dead MOSFET, and then, you know, I might not have a perfect match. Well, actually, if it's an Asus card, because Asus likes to use the same MOSFETs over and over and over again, so if it is an Asus motherboard, Asus GPU, then I'll probably have a correct like the correct MOSFET for the card, just if I pull these. So, yeah. It's a real shame that it died, though. And I feel like, you know, the thing is, now going forward with the other 290Xs, I won't bother with trying to, like, preserve the stock VDDCI VRM. I'll just, like, replace it. Because it's not that hard to replace. Like, compared to VCore, it's actually really easy to do the VDDCI. It's not anywhere near as difficult to replace that one. And also, it just saves, like, you don't have to fight with the controller afterwards. You can just pull the controller, right? Bolt on the power, bolt on that, and like life is so much better when you don't have to worry about the drivers turning off your various rails. And while the drivers, even on a reference 290X, the memory VRM, like you can't, like the driver can't talk to that. It's too stupid. Literally, the controller for it is too stupid. Like, that's a controller that's set to 1.5 volts static, and it's always 1.5 volts. VDDCI is hooked up to the 3567B, which is why the VDDCI rail can shut down when the driver initializes, because the driver talks to the 3567B for VCore control. So it can notice things like, hey, VCore is all messed up, and then it'll turn off your memory controller, which is really annoying. And then you have like 0.95 volts down here, which... oh, and reference cards, you just need to pull a transistor, and then that works. And there's a LDO over here for 1.8 volts, which on reference cards, again, there's another transistor that you pull, and that solves that one. So yeah, now the biggest annoyance is just like taking the e-power off. Like disconnecting this mess is gonna be like no fun. But yeah. Well, I got a little bit better at hot air rework, so that's a win. I you know have well actually I completely reprogrammed the controller on there, which is neat. So that's nice. You know, learned how to like finally like I've not been brave enough to reprogram a controller on a working GPU because it's like if I reprogram it on a working GPU, then like I could potentially break the card or something. But here it's like, well, it's not gonna get worse, so it's already not attached to anything. So I reprogrammed that, which is a first, right? Replaced MOSFETs, which is a first. So got better at soldering. Unfortunately, I also learned that you know what, you should just not try to you shouldn't try to negotiate with the AMD drivers. You should just you know do VDDCI the hard way the first time instead of trying to do it like well actually this is the easy way, right? The hard way is trying to get the drivers to stop turning your VDDCI off, and yeah. Hopefully I'll remember this time, because the funny thing is, I think well, I have an R9 290 that I'm working on, and that one actually has the VDDCI e-powered, but the card doesn't turn on probably because it tries to boot at like 0.7 volts, and if I'm not mistaken, the cards don't boot at 0.7 volts. But that's like, actually, now that I've freed up this e-power, I could just use this on that card. But no, that card is like there's a different priority with that card. Like that's a project where I'm trying to do things in a specific way, so I'll just keep doing them that way. And man, that thing is such a mess. I really wish I had realized that I could do this kind of horrible. Like it looks really horrible, but compared to some of the other soldering I've done, like this is actually more like it takes less space and it's more. Like, yeah, it's more space efficient, and it's easier to work with than trying to do, like, anything else, really, that I've tried. Well, my favorite way is what I did on the GTX 480, where I had the e-power so close, like, the actual V-core edge of the e-power is just jammed right up against the V-core of the card, and I just did a solder bridge right across, and that works amazing. It's really short. It's a really nice, thick, wide connection. But, you know, you don't always get cards where your memory VRM is shifted so far out of the, again, you know, memory VRM is just jammed somewhere in the middle of nowhere, and so you can do whatever you want with vCore. Yeah, not all cards are designed like that, so, anyway, but that 290X has a horrible way of having the vCore attached, so, and I'm also, I think I might have shorted out, like, 0.95 volts with 12 volts on that card, so... Anyway, now I have an excuse to go back to that one as soon as I scrap this thing for, you know, free the e-power, scrap it down. This is now at least configurable, which is like this is less janky to work with now. This right here. This is a lot better in terms of how it works. It also like it used to have a ton of load line droop, so now it doesn't have that because I got rid of the load line settings on it. So now it should behave a little bit more, well, like just a straight voltage output instead of something that floats around depending how much current it outputs, which is like, that's the way it's supposed to work, but anyway. Like when you're e-powering things, it's going to lose voltage just because of your because of my terrible power connection, right? Like, I don't need the controller itself lowering the voltage intentionally. Just like, no, just let my terrible soldering work do that. Yeah, so that's it. This doesn't work. I am very disappointed. Like, at least, you know, it's just, you know, well, yeah, I'm disappointed, but that's, you know, it could have been worse, I guess. There. Actually, yeah, so if I had finished it, the plan was to run this on like water cooling or LN2 or something. Actually, probably dry ice, just because LN2, like the worst part is like this isn't even a Matrix Platinum, so the core probably wasn't that great to start with, like wasn't that great anyway, so it's not that big a loss. It's not like I destroyed a golden 290X with all probability, but yeah, you know, still, it's not like the card was 60 quid, so... And it's not like I'm recovering 60 quid worth of parts on it. There's no way you're getting 60 quid worth of parts out of a 290X, but yeah. At least, at least I kind of learned to, well, my technique improved a little bit. But yeah. I really wish this had been a success, because I put so much, like, I sank a lot of time into it, and now it's just like, now I need to take it all apart. And I guess with 290X6 going forward, what I learned is, like, don't commit to having, like, a 200 amp power connection before you even know if the card will run Firestrike, right? Like, that I think was the other biggest mistake I made, was just, like, because I already had the card, like, it would run GPU-Z render test when it was on its own VRM. So I was like, oh yeah, it'll be fine as long as it, just turns on with the e-power. It's fine. We don't need to check if the driver is still happy with the way things are running. Because the thing is like, what I guess I forgot is, like, the most recent e-power before the 290X that I did was a GTX 480. NVIDIA cards are stupid. So on NVIDIA cards, as long as you have all the voltages running, for whatever reason, they're not going to do things like AMD. Like, if you can get the card to boot, it won't shut down once the drivers initialize. Whereas AMD cards, once the driver initializes and it realizes what you did, it'll get very upset with you and turn it off, which is not great. But anyway, it's not like, like, this isn't the last e-power I'm doing by any stretch of the imagination. As I mentioned, I do have a pile of dead 290Xs that, well, I can work on those instead of this. I also have, like, I want to e-power a GTX 590. I want to, like, e-powers are my, like, I think e-powers are the coolest voltage modification you can do out there, just because they're so freaking ridiculous. But at the same time, is, like, I'm definitely not that great at them. And 290Xs are probably, like, if I had to go, like, rank cards by difficulty, GTX 480, easiest. By far the easiest to e-power. Most difficult, I would say 290X, and then anything with a VPP rail. Actually, no. AMD cards, the only thing that's more difficult than a 290X is AMD cards with VPP rails. So, Vegas, Fury X's, anything with GDDR6, anything with HBM or GDDR6, that's the next, like, that's harder than these, because those have power sequencing concerns. So if you don't have the VRM fire up in the correct order, like, if you don't have the VRMs fire up in the correct order, you're going to blow up the memory, and then the card isn't going to work, and you're just, you're screwed. So anyway, that's it for this video. And whoa, this turned way longer than I thought it would. Like, this was not meant to be 32 minutes. This was meant to be, like, maybe 20 minutes or something, but I guess I guess I just can't shut up, can I? Oh well, yeah. Hopefully I'll be more, like, I hope the other ones don't have dead cores. Like, that's the most annoying thing with this. It's just like, you really don't know if all the effort is worth it until, until it turns on. And then it, like, well, actually, there was a GTX 480 where I e-powered it, like, successfully. Everything was going great, and then, the day after I finished and had everything up and running and it was perfect and amazing, the day after I was done with it, I tried to run it again, and it was dead. And that's worse. That's worse. It just randomly up and dies on you 24 hours later. Anyway, so yeah, that's it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, well, which evidently is just giving money to people on eBay for cards that don't work. I do have a Patreon. You can support me through that directly. And then there's also the AHOC Teespring, where you can pick up shirts, stickers, posters. And yeah, there's a poster of an actually successful e-power mod, which is the GTX 480. I think I should run that, just like run that on a live stream or something, just to prove that thing actually works. Because I've never shown it running on video. Like, it does run, I've just not shown it. And I have another GTX 480 I want to eventually e-power as well. Because but the problem with that, well, I'll make this video too long. So anyway, Patreon, Teespring, check out the links down in the description. They help out immensely with, well, funding. The thing is like the e-powers cost money, the cards cost money, the random bits of other cards cost money too, so you get the idea. Yeah. Thanks for watching, and goodbye.